My name is Ian Lambie and I'm one of Historic Environment Scotland's District Architects. A main part of my job and a privilege is looking after Glasgow Cathedral. This impressive and amazing building has been here for over 800 years. And to conserve such a historic structure, it is necessary to understand its historical development and the fabric's significance. As you follow me, we will learn from the tried and tested practices of our ancestors, and we will find out how they created a building that has stood the test of time. Glasgow Cathedral today is situated a little to the east of the modern city centre. However, the cathedral and its monastic surroundings were the reason why the original city of Glasgow was founded back in the 11th century. Our first knowledge of the site is of a 7th century monastic foundation that was dedicated to St Mungo, also known as St Kentigern. Though the cathedral, as we see it today, dates from a refoundation at the early 12th century by King David I in 1114. That Romanesque cathedral was enlarged in the 1180s, but in part of the building process it was burnt down by fire. We know of the cathedral because during the 1990s, when the heating works were undertaken, the trenches exposed the cathedral's foundations. A small fragment of the Romanesque cathedral still survives in the cathedral crypt, also known as the lower church. The cathedral building we know today originates from the end of the 12th century and is mainly the result of the massive building programmes carried out throughout the 13th century. We can trace the development of the cathedral from scant historic records that survive, but also by changes in architectural styles within the building. During the 13th century, details in the Gothic style changed significantly as the decades of the century wore on. Here we see a plan of the late 12th century Romanesque cathedral of Bishop Jocelyn. Now we see the beginning of the present cathedral, commenced by Bishop Walter in the 13th century with the formation of the east crossing, transepts and a larger nave on the west. However, work to the nave was halted after 1233 for several decades when Bishop Bondington commenced the greatly enlarged eastern arm as a setting for the shrine of St Kentigern. This plan shows the relationship of the sequential expansion. So by the end of the 13th century, most of the present cathedral had been constructed. Archaeological survey has revealed that much of the fabric of the earlier 12th century cathedral was reused in the later rebuild and expansion. Here on the west front, two towers were subsequently added. A bell tower to the north in the early 14th century and another on the south containing a library in the early 15th century. This early 19th century view of the west front shows these unsymmetrical towers that were subsequently demolished in the 1840s. The Victorians deemed these two towers that were asymmetrical of a poor status and also poorer condition, and subsequently they looked at replacing them with an elaborate scheme for two western towers. After much controversy, unfortunately monies ran out, and so a more modest 13th century design was considered and taken forward, and here we have it here. Though the cathedral still stands much as it was in the medieval period, virtually all of the extensive cathedral precinct buildings have disappeared. This illustration shows us the precinct as it might have stood in the early 16th century. Though these buildings were dismantled after the 16th century religious changes, you can still see the reused stonework in the later 17th century courtyard walls. Because stone is a high quality material and traditionally was constructed with softer lime mortar, it has made it easier for this material to be deconstructed without damaging it for its reuse elsewhere. Here is sustainability in practice. In 1406, the central tower and spire collapsed after being struck by lightning. This caused extensive damage to the east of the cathedral. Particularly damaged were the chapter house and choir aisle vaults. Over the next 100 years to 1508, these and the spire were repaired and reconstructed. As in previous building programmes, much masonry was reused, probably even to the extent of replacing the damaged window tracery in new stone, exactly matching the originals, that by the 15th century was in an archaic architectural style. This allowed for the sustainable reuse of the undamaged stonework. Repair has been a constant in the life of the cathedral, and one of the reasons it still stands today. So let's go inside and look at the late medieval adaptations and changes to the cathedral. We're now in the nave of the cathedral, looking towards the great east window. We see the massive volume of a cathedral built for medieval religious rite. With the mid-16th century Reformation, the change from Catholicism to the new Presbyterian religion, there was no need for such large religious spaces. Thus, most large cathedrals and abbey churches fell into ruin in Scotland. However, in the case of Glasgow Cathedral, its unique split-level layout helped its sustainable adaptation for the continued reuse of the expanding city. In the late 16th century and mid-17th century, the cathedral was split into three separate church congregations, thus allowing the cathedral to survive when the surrounding presbyteries and Canons Alley were lost. This adaptation is a good example of making the best of an existing building. Our ancestors, knowingly or not, considered sustainability and reuse. The cathedral's eastern arm is two-storey. Along with the western arm of the nave, this allowed the cathedral to be partitioned into three. Though this continued use unfortunately resulted in the loss of all the pre-Reformation fitments. Fortunately, in the adaptation, the building of walling to separate the choir from the crossing in 1635 reused and saved the medieval rood screen. Another wall to the west of the crossing was built to separate the nave in 1647. Here's an 18th century view of the interior. As that century progressed, upper galleries were built in the choir and nave churches to accommodate the enlarging church congregations. Thus, for 200 years, the new adapted joint use saved the cathedral, until a renewed appreciation of medieval architecture in the early 19th century. This led to the relocation of the nave and lower church congregations, and on removal of the later masonry partitioning galleries, the whole medieval volume of the interior was reopened. Adaptation of this building was made possible because the cathedral's unique internal layout was flexible and able to be adapted, making it easier to rearrange the spaces for new uses. Today, building designers should increasingly be thinking along these lines too. The pulpit is a nice little example of continuity and reuse. In the 1850s, when the cathedral was opened again, the 16th century panelling from the time-worn and damaged pulpit of the lower church was reused in the new pulpit for the remaining congregation in the choir. The mid-19th century also saw a large conservation project on the repair of the time-decayed high-level stonework of the cathedral. The weather-eroded pinnacles, parapets and upper gables were all substantially rebuilt. When considering the current conservation work on the cathedral masonry, we assess the areas most at risk, and we are generally concentrating on the weather-exposed cathedral gables and high-level masonry. But one of the worst facades of the building for decay was the sheltered east end. Heavy smoke pollution deposits from the many chimneys of the 18th to mid-20th century industrial city settled and formed thick, smothering crusts on these sheltered areas of the cathedral stonework. These crusts, with rainwater, acted like acidic poultices, dissolving the stone beneath. Our masons had to carefully chip off the hard, tarry, sulphurous deposits to allow the stonework below to breathe. Today we are facing risks from climate change. More wetting and drying cycles are accelerating the decay of our stonework. The corrosive acidic pollution not only attacked the stonework, it also attacked the stained glass that had been installed in the great 19th century restoration. Here I'm holding a piece of the Munich glass that was installed in the 19th century, And by the early 20th century, the pollution was so bad that the corrosion had actually started to etch the glass and had to be replaced in the mid-20th century. We're now about to see the north side of the cathedral, where masonry, conservation and repair work continue today on the north transept. Today we have a very large metal scaffold, but you can still see evidence of the original timber scaffolds used in constructing the cathedral. Notice these small square stones under the windows. These were put log holes where the vast amount of timber scaffold was attached to the building when it was constructed. And you can see with the modern scaffolding how much there was used. In the medieval period, the sandstone quarry was on a ridge nearby to the west. By the 19th century, stone had to be brought in by railway from quarries in Lanarkshire up to 20 miles away. Now, with our current conservation work, stone has had to be transported from northern England and East Scotland more than 100 miles away. Stone is a low carbon material to extract, so the transport makes up a significant part of its carbon footprint. Therefore, sourcing as locally as possible, as they did in the past, helps to keep down the carbon footprint of these repairs. Ironically, the original medieval local stone has proved much more resilient to weather decay than the Victorian replacement stone. Here, our Historic Environment Scotland masons are cutting out severely weather-decayed stone, and they are using the same sustainable methods as their medieval forebearers. It's only when you get up close that you realise the size of the individual stones and the energy required to transport the new stones to site, carve them, and hoist them up the scaffold to get them into position to be installed. We're now all the way up at the gable of the north transept. Johnny Clark, who is the Historic Environment Scotland's works manager for the cathedral and a stonemason, tells us more about the current repair work.
One of the challenges is the actual size of the stones that are getting replaced, and this is one of these fleur-de-lis. That this one's actually in good condition in comparison to the others that's going to be replaced, so it's a massive stone. So firstly you've made your templates all up here, and it's great having the actual depot close to the cathedral as well, because you will have to revisit making these templates because nothing's true or square on this monument.
And so this is where our tour ends. We've seen how this magnificent building has changed and adapted through its 800 years of history, and the repair work that has gone on to maintain the fabric in the past, and the current work that has been carried out to keep the fabric of the building in its current state. As we face new challenges due to climate change, it's important to remember that we need to make the most of what buildings we already have in order to be resource efficient and support net zero climate change targets. To find out more, you can visit our properties or find us online on the Historic Environment Scotland website and our social media channels.